Exercise 410 just wants you to name in their entirety some compounds. So we'll find the backbone, we'll name the backbone, we'll name each of the branches, and then we'll put all that together. So in this first one, the longest carbon chain you can find without going backwards or lifting up your pencil would be 1, 2, 3, 4, 5, 6, 7, 8 carbons long. And so we'll circle that. That'll be our backbone. Now we have 8 carbons, and so the prefix is for that backbone is oct. We have all single bonds in the backbone, and so the infix is AN, and it's a hydrocarbon. There's only hydrogen and carbon there, so the suffix is E. So the name for that backbone is octane. Okay, now let's think about the branches. This first branch on the left has only 1 carbon in it. The prefix for 1 carbon is meth. It is a branch, so immediately after the prefix comes YL. Next branch, same thing. So we only have 1 carbon, so the prefix is meth, and it's a branch, so immediately after that comes YL. This last branch has only 1 carbon, so the prefix is meth, and it's a branch, so immediately after that comes YL. Okay, so we have these 3 methyl branches, and we have a backbone that's called octane. So we want to put these in some type of order. We want to combine these to get a full, complete name. Now, the backbone name comes last. We're going to put the branch names in front of it. We have to do a couple things first. The first thing we have to do is to say where the branches are coming off of the backbone. And for that, you would want to see which branch gives you the lower number when you're counting from the end of the chain. So for example, this branch here, you would be 1, 2, 3 carbons away from the end of the chain. The branch on the opposite side, this one here, that's closest to the other end of the chain, that is 1, 2, 3 carbons from the end of the chain. So those tie. And then you look to see which one gives you, which direction gives you the lowest number for the second branch, if the first branch ties. So in the orange way, from left to right, we would get 4 for our second branch. For the blue way, we would get 6. And so the orange way gives us our lower numbers, so that's how we're going to number this chain from left to right. So 5, 6, 7, 8. Alright, so that means that this first methyl group is coming off of carbon number 3. In front of the branch, put a 3, and always between numbers and letters, put a dash. Our second carbon branch is coming off of carbon 4, so we'll put that in front of that branch name, always in between numbers and letters, put a dash. Our last methyl group is coming off of carbon 6, so we'll put that in front of the branch name, always between numbers and letters goes a dash. Now normally, you would just put the branch names in front of the backbone name, and you'd list them in alphabetical order for the type of branch. Here we have only 1 type of branch. They are all methyl branches. All 3 of these are methyl branches. So instead of saying 3-methyl, 4-methyl, 6-methyl, we can sort of combine them. And we can put all the numbers together, separated by commas, so 3, 4, 6. Always between numbers and letters goes a dash. The type of branch that we're smushing together is methyl, but when you smush these together, you have to be really careful to remember to put a prefix that tells you how many you've smushed together. And so we've smushed together 3, so the prefix would be tri. And the prefixes are really the same as the Greek prefixes when they're larger. If you have 2, it's di, 3 is tri, 4 is tetra, 5 is, and then from there on it just follows the Greek prefixes. Now those are prefixes for when you combine branches together. So here we combined 3 of the same type of branch. They always have to be the same type of branch if you're going to combine them together. We combined 3 methyl branches together, and that's where we're getting this tri from. So then you take the branch names and you put those in front of the backbone name, and that is your final name. So the name for that whole compound would be 3,4,6 trimethyl octane. Okay, let's try this next one. We have a ring. Anytime you have a ring, you want to separate in your mind the ring and the straight chain, and ask yourself how many carbons are in the ring. Well, this ring has 1, 2, 3, 4, 5, 6 carbons. How many carbons are in the straight chain? It has 1, 2, 3, 4 carbons. So which one has more? The ring, and so the ring is the backbone. So here, I'm going to circle that backbone so that we can clearly tell it apart from the branches coming off of it. So let's name the backbone. That backbone has 6 carbons, as we've seen, so the prefix is going to be hex. All single bonds in that ring, and so the infix is An. And it's a hydrocarbon. We don't see the symbols for any other elements, so we use the suffix E. Hexane. Now, it's not just any hexane, it's going in a ring, and so in front of that we'll put a little prefix cyclo to say that we're going in a ring. Then we have this branch, and this branch is a strange sort of branch. This is one of those branches that have branches. There are 4 carbons in this branch, so bute. It is a branch, so YL, and if you notice, this was the one that has the branch connected to the second carbon of that butyl group, and so it's called sec-butyl. And remember, those were those strange branches that you'd want to memorize that we went through in a previous video. So there's only that one branch, and the last little feature that you'd want to recognize is that normally, before we put this in front of our backbone name, we would want to say where it comes off of the parent chain. But because every position here is symmetrical, it doesn't matter where the sec-butyl goes. If the sec-butyl were connected to this carbon, that's really the same thing as where it is right now, because this moves in space. Imagine rotating it like a dial. And you can rotate it like a dial so that this branch is coming off of any one of what looks like these carbons would be. So because the entire molecule is symmetrical, the backbone is symmetrical, if you only have one branch coming off of a ring, you don't have to give a number for where it is, because every position is the same. And so this sec-butyl doesn't get a number, we just put that in front of the backbone name, and the whole name for that compound is sec-butyl cyclohexane. Okay. For C, the first step is to find the parent chain. And parent chain is the longest chain you can find without going backwards or lifting up your pencil. So here, let's see, there are a couple different ones that you can find that might tie. So one would be 1, 2, 3, 4, 5, 6, 7. Another possibility would be 1, 2, 3, 4, 5, 6, 7. Notice that those tie, and they give you different branches. So look at the branch we have when we number the blue way. We have a branch with a branch. Then notice the branch you have when you number the green way. None of our branches have branches. So if there's ever a conflict, you want to number the backbone in the way that gives you the simpler branches. So in this example, that was that dark green way. None of these branches have branches. Okay, let's name that backbone or that parent chain as if there were no branches coming off of it. So first, we have 7 carbons. The prefix for 7 is hept. We have all single bonds. The infix for that, for all single bonds, is An. And we only have hydrogen and carbon, so the suffix is going to be E. So that would be heptane. Now, in terms of numbering this, we want to number this, or I should say, next let's name the branches, and then we'll worry about the numbering. So, our branch on the left is only 1 carbon, so the prefix is meth. And because it is a branch, immediately after that prefix comes a YL. So that's a methyl branch. In the other branch, we have 2 carbons there. The prefix for 2 carbons is F, And because it's a branch, immediately after that prefix comes YL. So that's an ethyl branch. Okay. Well, the backbone name comes first. The backbone name always comes last. And then we're going to put the branch names in front of it. First, we have to say where the branches are coming off of the backbone. Now, in this, we could number from the bottom to the top, or the top to the bottom. We want to number to give the first branch that we run into the lowest number. So here, if we number going from the top, the first branch we run into has a 2. If we number the other way, from the top to the bottom, 1, 2, 3, 4, 5, we have to wait until we're at carbon 5 to get our first branch. So we number the way that gives the first branch we run into the lower number, and that is the orange way of numbering. So we'll just fill that out, 3, 4, 5, 6, 7. Okay, the methyl group is coming off of carbon number 2. That's where it's attaching to the parent chain. So we'll put that in front of the branch name, always between numbers and letters goes a dash. The ethyl branch is coming off of carbon number 3 of the parent chain, so we'll put a 3 in front of that branch name, always between numbers and letters goes a dash. And so now we have our 2 branch names, and we just want to put them in front of the backbone name. Because they're different types of branches, this is a methyl branch, this is an ethyl branch, we can't smush them together, we can't combine them. You can only combine branches that are the same type of branch. And so we're going to list these separately, but what order will we put them in? We're going to put them in alphabetical order. So E comes before M, and so 3-ethyl will come before 2-methyl. Always between numbers and letters goes a dash. And so the full name for this will be 3-ethyl 2-methyl heptane. All right. Going to this next one down here. So for this next compound, first step, let's find the parent chain. It's the longest carbon chain you can find without going backwards or lifting up your pencil. So 1, 2, 3, 4, 5. It looks like that no matter which direction you go in, you end up with the longest carbon chain being 5 carbons long and having the same types of branches on it. So I'm actually going to do this in a different color. Say 1, 2, 3, 4, 5. Okay, so that's a parent chain. That's our parent chain. We have 5 carbons there, so let's name that as if there are no branches coming off of it. Then we'll worry about the branches. 5 carbons, and so the prefix is pent. There's all single bonds in that chain, and so the infix is AN, and it's a hydrocarbon, so the suffix is going to be E. It's only hydrogen and carbon in that backbone. So the parent chain is named pentane. Now let's name each of the branches. Our first branch here has only 1 carbon in it, so the prefix for that will be meth. And it is a branch, so immediately after the prefix comes YL. For our second branch there, our second branch on the bottom, we also have 1 carbon, so the prefix is meth, and it is a branch, so immediately after that prefix comes YL. We have one other branch on top, and the other branch on top is a branch that has a branch. So that would be on that table of those weird branches that we went through in a previous video that you'd want to commit to memory. And this is an isopropyl branch. It has that snake's tongue, so it's iso, and it has 1, 2, 3 carbons, so it is prop. And it's a branch, so YL, isopropyl. Okay, well our backbone name comes last, always, and then we just need to give, we have to number this chain so that the first branch we come across gets the lowest number. Now, if you notice, no matter how you number this chain, you end up getting the same numbers for all of the branches. So if we number it the green way, then we have a methyl branch at 2, another methyl at 4, and an isopropyl at 3. So 2 methyl, 3 isopropyl, 4 methyl. If we number the blue way, we have a methyl at 2, a methyl at 4, and an isopropyl at 3. So 2 methyl, 3 isopropyl, 4 methyl. So either way, we get the same number for the branches. So I'm just going to use our original way, the green one. This first methyl branch is coming off of carbon 2 in the backbone, so we'll put that number in front. Always between numbers and letters goes a dash. The isopropyl group is coming off of carbon number 3 in the backbone. And so we'll put a 3 in front of that branch name. Always between numbers and letters goes a dash. The third branch is coming off of carbon 4 in the backbone, so we'll put 4 in front of that. Always between numbers and letters goes a dash. So these are our 3 branch names. We have 2 branch names that are the same type of branch. We have 2 methyl branches, so what we can do is we can combine those. We can take the numbers, so 2 and 4, separate those by commas, and then always between numbers and letters goes a dash. The branch type that we're putting together is methyl. Meth because they both have 1 carbon, YL because they're both branches, and the thing you never want to forget when you smush these together is you want to put a prefix to tell people how many of that type of branch you smushed together. So we smushed 2 methyl branches together, and so put in that prefix di. Okay, so we have a 3 isopropyl branch and we have a 2,4-dimethyl branch. Now we just have to order those in front of the backbone name. And so the way we're going to do that is by alphabetizing them. The one thing you want to watch out for is the prefix does not count in the alphabetization. So we're going to compare I here, not with D, but with M. And I comes before M, so 3 isopropyl will come before 2,4-dimethyl. And the full name will be 3 isopropyl 2,4-dimethyl pentane. So that is the beautiful, beautiful name for that beautiful compound. Okay, let's try to name E. First step is to find the parent chain. Parent chain is the longest carbon chain you can find without going backwards or lifting up your pencil. Now, here you have a couple possibilities. You have 1, 2, 3, 4, 5, 6. That's one possibility. Or notice you could also go 1, 2, 3, 4, 5, 6. So that ties. Now, if it ties, you want to choose the carbon chain that has the simpler branches. If you do the orange way, notice you have a branch with branches. You have that tert-butyl branch there. If you do it the blue way, none of your branches have branches. You have 2 methyl groups and an ethyl group. And so the blue way will be the name, the backbone for this. So let's name that backbone as if there were no branches coming off of it. It's got 6 carbons, so the prefix is hex, all single bonds in it, so the infix is AN, and it's a hydrocarbon, just hydrogen and carbon in the molecule, so the suffix is E. So hexane is the name for that backbone. Now let's name the branches. First, our branch here on top, only 1 carbon there, so the prefix is meth. And it's a branch, so immediately after that comes YL. The next branch, same thing, 1 carbon, so the prefix is meth, and it's a branch, so immediately after that comes YL. We have a third branch at the bottom. This one, though, has 2 carbons on it, 1, 2. The prefix for 2 carbons is F, and because it is a branch, immediately after that will come YL. So those are the names for those individual branches. Next, we want to put the numbers, we want to say where those branches connect to our backbone. And to do that, you want to number the chain so that you give the first branch you run into the lowest possible number. So if we numbered left to right, we'd have 1, 2, 3, 4. The first branch we'd run into would have a 4. This would be our first branch, and that would have a 4. If we numbered it the other way, 1, 2, the first branch we would run into would be on carbon 2, and those would be these methyl branches. So you get a lower number for the first branch you run into if you number the blue way, and so that is how we will number this backbone. Okay. Our 1-methyl group is coming off of carbon 2. That's attached to the second carbon in the parent chain, so we'll put a 2 in front. Always between numbers and letters goes a dash. For our second methyl branch, it's also coming off of carbon 2, so we'll put a 2 in front of that. Always between numbers and letters goes a dash. The ethyl group is attached to carbon number 3 of the parent chain, so we'll put a 3 in front of that branch. Always between numbers and letters goes a dash. Now we have two branches that are the same type of branch. They're both methyl branches, so we can combine those. We can put the numbers together separated by commas, so 2, 2. Always between numbers and letters goes a dash. The type of branch that we're smushing together is methyl, meth because one carbon, YL because they're branches. And then never forget that to put a prefix to let people know how many branches you put together. Now we put 2 together, so we're going to use the prefix di. So those branches together are going to be 2,2-dimethyl. So now we have our 3 puzzle pieces, and we want to put them in the right order. The parent chain always comes last, so hexane here will come last. And then you want to alphabetize the branches. But remember that the prefix is not included in the alphabetization, just the number of carbon prefix. So M comes after E, so that branch will come after this branch in the name. E comes before M, so the branch that starts with E comes first, 3-ethyl, and then after that you'll have 2,2-dimethyl. Always between numbers and letters goes a dash. So the full name for this compound would be 3-ethyl 2,2-dimethyl hexane. Okay, let's try naming F. So first we want to find the parent chain. The parent chain is the longest chain of carbons you can find without going backwards or lifting up your pencil. So we have a ring here, and anytime you have a ring, you want to separate the ring and the straight chain in your mind. How many carbons are in the ring? Here we have 1, 2, 3, 4, 5, 6. 6 carbons in the ring. How many carbons are in what would be the parent chain in the straight chain? So here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. So which has more, the ring or the straight chain? The straight chain. And so the straight chain will be the parent chain. So we'll circle that parent chain so that it clearly stands out from the branches. And then we will just name that parent chain first as if there were no branches on it, and then we'll worry about the branches. So we've got 8 carbons. The prefix for 8 is oct. All single bonds. The infix for all single bonds is AN, and it's a hydrocarbon. It's just made of hydrogen and carbon. There's no symbols for other elements there, so the suffix is E. So the name for the parent chain is octane. Now let's worry about the branches. So here we have a branch with just 1 carbon, so the prefix is meth, and because it's a branch, immediately after the prefix comes YL. Similarly, this one down here, 1 carbon, prefix is meth, and because it's a branch, immediately after that prefix comes YL. For the next branch, this branch has 2 carbons, 1, 2, and so the prefix for 2 carbons is F. And because that's a branch, immediately after that prefix comes YL. Okay, now we get to the ring. How many carbons in the ring? We saw there's 1, 2, 3, 4, 5, 6. Let me move this so it's more clearly associated with the ethyl. So 6 carbons in the ring. The prefix for 6 is hex. And because it's a branch, immediately after that prefix comes YL, hexyl. But this is in a ring. And the way you say that you have a ring is you put a cyclo in front of the prefix for the number of carbons. So the name for that branch is cyclohexyl. All right. Now, we just have to number the backbone so that we get the lowest number for the first branch we run into. We could do it right to left or left to right. I already have the numbering for right to left written in. That's the green. And in that green scenario, the first branch you run into is on carbon number 2. If we go the other way, the first branch you'd run into would be on carbon number 3. Well, 2 is lower than 3, so we're going to number from right to left. So here we will have the cyclohexyl branch is coming off of carbon number 2. Always between numbers and letters goes a dash. The ethyl branch is coming off of carbon 4. Always between numbers and letters goes a dash. The first methyl branch is coming off of carbon 5. Always between numbers and letters goes a dash. And the second methyl branch is coming off of carbon 6. Always between numbers and letters goes a dash. Now we have 2 branches here that are the same type of branch. We have 2 methyl branches. So what we can do there is combine those. We can put the numbers together. So we'll put the lower number first, and we separate them by commas, so 5, 6. Always between numbers and letters goes a dash. The type of branches we're merging are methyl branches, meth because they both have 1 carbon, and YL because they're both branches. And then never forget when you merge those branches to put a prefix that tells you how many branches you've merged. So these are dimethyl. So 5, 6 dimethyl. Oops. Those. And di really just because we've combined 2 of those branches. All right, so we have our puzzle pieces. We just need to put them together. This octane, the parent name, will always come last. And for the others, the branches, we alphabetize them. So, and you remember you don't include the prefix for for the number of branches you've combined when you alphabetize them. So we're comparing M with E and with C. So C comes first in the alphabet between M, C, and E, and so that branch name will come first. E comes next, and so that branch name will come next, and M comes last, so the branch name with the M's will come last. Let me just make some room here. So, parent chain comes last. So what we've got here is 2 cyclohexyl, 4 ethyl, 5, 6 dimethyl octane. And that would be the correct name for that beautiful, beautiful molecule. 2 cyclohexyl, 4 ethyl, 5, 6 dimethyl octane. Okay, G. Let's try to name this one. So in this one, first step is to find the parent chain. Now, there are several that look tempting. Let's try them out. We've got 1, 2, 3, 4, 5, 6, 7, maybe. How about 1, 2, 3, 4, 5, 6, 7? So that ties. And there's still another one. Imagine if you had 1, 2, 3, 4, 5, 6, 7. So we've got several that tie here. What we want to do is to find which one has the simplest branches. Which one of these has branches with the fewest branches? Now if you choose this orange one, look at how crazy those branches are. You have a branch with a branch on top, a sec-butyl branch, and you have a branch with a branch on the bottom, an isopropyl branch. So that's not the best contender. Let's compare that with the light blue one. So this one is a little better. Now we have a methyl and an ethyl on the bottom, so those at least don't have branches, but we still have the branch with a branch on top, the sec-butyl branch. So getting better, but if we could find one that has no branches with branches, that would be preferable. So if you look at this dark blue one, if we circle that backbone, notice we have a methyl, an ethyl, a propyl, and a methyl. None of those branches have branches on them. So those are the simplest branches, and so that backbone is the one we're going to go with. We go with the backbone that gives us the simplest branches if you ever have a tie. Okay, so now let's name this backbone as if there were no branches on it. We have 7 carbons. Prefix for 7 carbons is hept. All single bonds between those carbons, the infix for all single bonds is AN, and it's a hydrocarbon. We don't see the symbols for any other element, so the suffix is E. So the name for that backbone is heptane. Let me just erase those numbers. We'll come back to the numbering later. Let's focus on the branches now. So let's try to name the branches separately. We have a branch with just 1 carbon. The prefix for 1 carbon is meth. And it's a branch, so immediately after that prefix comes YL. Below it, we have a branch with 3 carbons, 1, 2, 3. The prefix for 3 carbons is prop, and because it's a branch, immediately after that prefix comes YL. On the right side, we have a branch with 2 carbons, 1, 2. The prefix for 2 carbons is F, and because it's a branch, immediately after the F comes YL. So that's an ethyl branch. And then at the very bottom, we have another branch. There's only 1 carbon there. The prefix for 1 carbon is meth, and because it's a branch, immediately after that prefix comes a YL. So those are our branch names. Now, we want to number the backbone in order to say where all of these branches are coming off. Now we can number the backbone from top to bottom or bottom to top. We want to number the backbone to give the lowest number to the first branch that we come across. So if we number it from the top to the bottom, we would have 1, 2, 3. We meet our first branch on carbon number 3. If we go from the bottom to the top, then you would have 1, 2. We'd meet our first branch on carbon number 2. And so 2 is a lower number, so that's how you're going to number the branch, the blue way. So I'll just fill those in, 3, 4, 5, 6, 7. So our methyl group at the bottom is coming off of carbon 2, always between numbers and letters goes a dash. Our ethyl group is coming off of carbon number 3, so we'll put that in front, always between numbers and letters goes a dash. The propyl group is coming off of carbon number 4, so we'll put that in front, always between numbers and letters goes a dash. And the methyl group is coming off of carbon number 5, always between numbers and letters goes a dash. Now, the parent chain always comes last. We're going to put the branch names in front. Before we start putting them in alphabetical order, notice that we have 2 branches that are the same type of branch. We have 2 methyl branches. And so we're going to combine those. We'll put the numbers first in from smallest to largest, so 2, 5, always between numbers goes a comma, always between numbers and letters goes a dash. The branches we're combining are methyl branches, meth because they both have 1 carbon, and YL because they're both branches. And whenever you combine these branches together, don't forget to put a brief prefix to tell people how many of those types of branches you've combined. So those two branches are going to get smushed together, and together they'll be called 2,5-dimethyl. So now we have our puzzle pieces, and we just have to put them in the right order. So we're going to alphabetize them. And remember that when you alphabetize, you don't include that pink prefix that tells you how many branches you smush together. You use the number of carbon prefix. Or whatever comes first, just not the die there. So we have an M, we have an E, we have a P. E comes first in the alphabet, and so the branch with that letter will come first in the name. M comes next in the alphabet, and so the branch with that letter comes next in the name. And P comes next in the alphabet, so the branch with that letter will come next in the name. Always between numbers and letters goes a dash, and so the full, beautiful, complete name for this is 3-ethyl-2,5-dimethyl-4-propyl-heptane. Rolls off the tongue, something you might considering naming one of your children. Let's try H. So with H, first step is to look for the parent chain. Parent chain is the longest carbon chain you can find without going backwards or lifting up your pencil. And so here, let's see, one we can find is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And it looks like no matter any other way you number it, that's the longest you're going to get. So that is our parent chain. Okay, so next we will want to name that backbone. So we have 10 carbons. Prefix for 10 carbons is dec. All single bonds, so the infix is AN, and it's a hydrocarbon, so the suffix is going to be E. Only hydrogen and carbon in the molecule. So there's our backbone, decane. Next we'll name each of the branches. Our first branch has only one carbon, so the prefix is meth. And it's a branch, so immediately after that prefix comes YL. Our next branch has, two carbons, 1 and 2, so the prefix is F. And because it's a branch, immediately after that prefix comes a YL. Our last branch here is a branch that has a branch, so it's one of those odd branches. We've got 1, 2, 3, 4 carbons. Prefix for 4 is bute. It's a branch, so YL, and it's coming off of the branches attached to the parent chain through the second carbon, so it'll be sec-butyl. So here we've got our puzzle pieces. We just have to put them in the right order. Decane, the parent chain, we know comes last, and we have to alphabetize these others. Oh, sorry, before we do that, we just have to number them, say where they're coming off. Now this green way of numbering gives us the lowest numbers for the first branch we run into. If you numbered it the other way, you'd see you'd get a larger number for where the sec-butyl attaches, whereas here the methyl is attaching at carbon 2. So the first branch we run into, this way of numbering, is smaller than the first branch we would run into the other way. So the methyl group is coming off of carbon 2. Always between numbers and letters goes a dash. The ethyl group is coming off of carbon 4 here. Always between numbers and letters goes a dash. The sec-butyl group is coming off of carbon 5. Always between numbers and letters goes a dash. So now we know where those branches are coming off of the backbone name. Coming off of the backbone. So now we just want to alphabetize these. Now watch out. If you see this dash here in those common names, it happens in the case of sec-butyl and also in tert-butyl. If you see the dash, then you don't use this prefix for alphabetizing. So when we try to alphabetize these, we're going to compare B for butyl with E for ethyl with M for methyl. So anytime those common names have that dash there, which is the case in sec-butyl and tert-butyl. You don't use the thing in front of the dash to alphabetize. So B comes first, and so 5-sec-butyl will come first in the name. E comes next, and so 4 in the alphabet, and so 4-ethyl will go next in the name, and then M comes next in the alphabet, so 2-methyl will come next in the name. Now always between numbers and letters goes a dash, and so the full beautiful name for this compound would be 5-sec-butyl 4-ethyl 2-methyldecane. 5-sec-butyl 4-ethyl 2-methyldecane. Okay, I'm going to continue doing the rest of these exercises in a separate video because I don't want to make these videos unduly long. So for now, here's up to H for